The view of the starry night sky is simply overwhelming. Yet, as dazzling as it may seem, it's important to remember that all the countless formations sparkling toward us only represent a mere fragment of the universe, a fraction so infinitesimal that it fails to capture the true scale of the cosmos. From our limited earthly vantage point, we're only able to peer into a small portion of the grand design, and because of this, the exact shape and extent of the universe remain elusive. But this limitation immediately gives rise to one of the most fundamental questions in astronomy: what lies beyond the visible curtain of the cosmos? Could there be wondrous structures or phenomena lurking just outside our field of vision? Surprisingly, the answer might be yes. According to some compelling data and observations, there could be a colossal structure or force beyond the observable universe, one so immense that its gravitational arm may already be stretching toward us. To understand why our view of the cosmos is inherently limited, we need to consider the concept of the observable universe. Essentially, the universe has placed natural blinders on us. The observable universe defines the cosmic bubble that contains all the light and information that has had enough time to reach us since the Big Bang. Assuming the universe is isotropic and homogeneous, meaning it appears the same from any direction or location, we're left with a spherical field of vision around our planet. Yet every point in space has its own observable universe, and while these spheres can overlap, the boundary of what we can see remains finite. How far can we actually see? You might assume that since the universe is about 13.8 billion years old, that distance would be 13.8 billion light-years. But that's not the case. Due to the relentless expansion of space itself, the current distance to the edge of the observable universe is roughly 46.3 billion light-years. This expansion isn't the result of galaxies moving through space, but rather space itself growing, stretching and pulling distant objects away from us. Light from the farthest objects we observe was emitted when they were only around 40 million light-years away. Since then, the stretching of space has expanded that distance immensely. This means that looking deep into the cosmos is essentially the same as looking back in time. The farther we gaze, the older the light we receive. However, because these ancient signals often originate from beyond the event horizon, we can't know what's happening there now. This naturally leads to speculation: is something massive, perhaps an invisible giant, lurking just beyond what we can see? It might sound like science fiction, but some researchers think it's possible. Despite the limitations of our observational tools, there are signs pointing toward a mysterious force exerting its influence from beyond the known universe. More specifically, several years ago, astronomers detected an anomaly that seemed to contradict everything we thought we understood about cosmic motion. According to standard cosmological models, galaxy clusters should be moving randomly with respect to the cosmic microwave background radiation, CMB, the ancient light left over from the Big Bang. This radiation provides a snapshot of the early universe, a sort of cosmic wallpaper that helps scientists detect irregularities. Between 2001 and 2010, NASA's WMAP, Wilkinson Microwave Anisotropy Probe, mission studied this background radiation. But when a team led by Alexander Kashlinsky analyzed the data, they noticed something bizarre. Instead of detecting random movement, they discovered a consistent, uniform flow of galaxy clusters in a single direction, something that simply shouldn't exist according to current theories. Even more astonishing, this flow appeared to accelerate with distance. This suggested that the galaxies weren't just drifting aimlessly, but were being pulled by a vast, hidden force, something enormous and far beyond the edge of the observable universe. This strange movement was named the dark flow. And as the years passed, the mystery only deepened. By 2010, the number of galaxy clusters observed to be participating in this mass migration had doubled, from 700 to around 1,400. Though some variation existed in directional segments, the data as a whole showed a clear, coordinated movement. According to Kashlinsky, the observable matter within our universe couldn't account for this. Something colossal was exerting gravitational influence, pulling entire clusters of galaxies with it. But what? And where? Unfortunately, since this supposed structure lies beyond the observable boundary, we can't directly see or study it. We can only infer its presence based on how it affects visible matter. Kashlinsky, working at NASA's Goddard Space Flight Center, put it bluntly, we don't have enough information to see what it is or narrow it down. The only thing we can say with certainty is that somewhere far away, the world is very different from what we see locally. Whether this is another universe entirely, a massive superstructure, or a warping of space-time, no one knows for sure. Unsurprisingly, not everyone in the scientific community is on board with the dark flow theory. Critics argue that such a flow shouldn't exist, and that earlier studies might have been flawed. One major criticism is that the WMAP data didn't properly account for the anisotropy, the directional variations, of the cosmic microwave background. Additionally, follow-up observations of over 550 supernovae showed no signs of a coherent flow, instead displaying motion patterns consistent with existing cosmological models. Further complicating the issue, the European Space Agency's Planck satellite, which provided even more precise data than WMAP, failed to find evidence of dark flow. According to this data, there was no unexplained mass migration, no giant cosmic tug-of-war. So does this debunk the theory entirely? Well, it depends on whom you ask. Kashlinsky continues to stand by his work, arguing that the findings are based on over 1,000 galaxy clusters observed up to 3 billion light-years away. He maintains that this can't simply be statistical noise. And if he's right, if this mysterious flow really exists, then something must be waiting out there in the dark, beyond our current horizon. Of course, this brings us to an even more profound question: what lies beyond the observable universe? While definitive answers remain out of reach, several exciting theories attempt to peer beyond the cosmic veil. The simplest of these suggests that the unobservable regions of the universe mirror the structure of the visible ones. If we apply this logic to an infinite universe, then everything that can happen, does happen. Somewhere out there, a solar system identical to ours exists. There could be another Earth where you ate cereal this morning instead of toast, or skipped breakfast altogether. In another version, you might have made a radically different life choice, like robbing a bank. Some researchers even believe that a copy of our observable universe exists, identical down to every atom and action. It's a wild concept, but one that follows from the idea of infinity. If the universe is infinite, then all possibilities must play out somewhere. Alternatively, some scientists argue that our universe is not the whole story, but just a bubble in a vast multiverse. This concept proposes that many bubble universes exist within an eternally inflating cosmic sea. Each bubble could contain different physical laws and constants, universes where gravity is stronger, or time flows backward. String theory supports a similar notion, proposing that every possible configuration of matter and energy exists somewhere. According to this view, we're only here because one of these countless universes just happens to support life. If true, the implications are staggering. Reality could be far more complex and vast than we ever imagined. And while the debate continues, one thing remains certain: the more we learn, the more mysterious the universe becomes. The dark flow, whether real or a misinterpretation, serves as a reminder of how little we truly know about the cosmos. It pushes us to look further, think deeper, and question the limits of our understanding. So, what really lies beyond the observable universe? A hidden colossus? A neighboring cosmos? An infinite sea of alternate realities? Only time, and science, will tell. If you enjoyed exploring this mind-bending topic, make sure to subscribe to Space Lab and join us as we continue to uncover the mysteries of the universe. Give us a thumbs up if you found this fascinating, and let us know your thoughts in the comments. Until next time, keep looking up. Thanks for watching Space Lab, where the universe unfolds, one mystery at a time.